This is a video lecture for Math 140 for Thursday, April 16th. And the topic today is the law of sines. We're now getting into chapter 5. And I'm going to change something about these video lectures. These are quite large files and it takes me quite a lot of time to upload them, so I'm going to start breaking them into parts. So today's topic will be divided into two parts. This is part 1. And what I first want to do is talk about some motivation for the law of sines. If I gave you guys a problem here and I said, suppose we have a triangle that looks like this. And this is a right triangle, and this side length is 150, and this is 250. And I said, solve this triangle, okay? You guys could do this. We already know how to do this. We could use our trigonometric functions. We could use a Pythagorean theorem, and we could solve this triangle for every angle in the triangle and for the hypotenuse here. So we can solve this. However, if I gave you guys this triangle, which also has a side length 150 and 250, and an angle here of 30, this triangle we would not be able to solve with what we know right now, because this is not a right triangle. So in this case, we need to use either the law of sines or the law of cosines to solve this triangle. Okay, so the point of the next couple days is we're going to be learning about the law of sines and the law of cosines, and we'll be learning how to solve triangles that are non-right triangles. How do we solve these triangles for every angle and every side? So that's the motivation. What I'm going to do now is I'm going to derive the law of sines. And you aren't really responsible for this on a test, but it's a nice little derivation. It's good just to see it. So what I want to do is prove the law of sines. So this is the proof or derivation of the law of sines. And what we're going to do is draw a triangle here that looks like this. And we're going to assume this is a non-right triangle. So this angle is not necessarily 90 degrees. Okay, and this, we're going to call this A, these angles A, B, and C. And these sides are going to be A, C, and B. How does this work as far as labeling, by the way? So there's 6 unknowns with the triangle, 3 angles and 3 sides. The angles are labeled with capital letters. The sides are labeled with lowercase letters. And the letters of the sides are always opposite the corresponding letter for the angle. So this is angle A. This would be side A. Okay. And let's suppose I want to solve this triangle. What I'm going to do here is I'm going to drop down. I'm going to create a perpendicular line here. I'm going to call this H. So I'm going to drop a perpendicular line down from angle B down to side B. Okay, and this creates a right angle. And then now I've created 2 triangles here. I've created 2 right triangles. This is right triangle 1. This is right triangle 2. And so let me label this 1 and 2. Let's go to right triangle 1. And what I'm going to do now is use what I know about the sine function. The sine of angle A. Sine is always the opposite over the hypotenuse. So the sine of angle A, of this angle A, is equal to H divided by C. And then I'm going to solve this for H. And this means that H equals C times sine of A. That should say sine. C times sine of A, okay? And then I'm going to go to triangle 2 and apply the same methodology. I'm going to take the sine of angle C. The sine of angle C is the opposite over the hypotenuse, which is H over A. I'm going to solve this equation for H. And by the way, the algebra we do like here to solve it for H, I just multiply both sides by A. The A's cancel out. And I get H equals A times sine of angle C. Okay. Now there's a property called the transitive property. If H equals something and H equals something else, that means those two somethings have to equal each other, right? So what this means is A sine of C has to equal C times sine of A, right? By the transitive property. So I get this equation, and then what I'm going to do is divide both sides by AC. I'm going to divide both sides of this equation by AC. Is that legal? Of course it is. I can do anything I want to one side as long as I do the exact same thing to the other. If I do this, the A's cancel out here, and the C's cancel out here, and this leads me to this equation, sine of A over the sine of angle A over the side length A equals the sine of angle C over the side length C, okay? This is known as the law of sines. So we basically just derived the law of sines. And there's another little piece to this. To write this completely, I need to write this, sine of angle A over A equals sine of angle B over B. If I wanted to do this for B as well, I could. So I'm not going to go through that. But this is the complete law of sines, sine of angle C over C. I'm going to box this, and this is the law of sines. So what this says is for any triangle, the sine, if you have any triangle, the sine of one of the angles divided by the length of the side opposite that angle equals the side of any other angle divided by the length of the side opposite to that angle equals the sine of the third angle divided by the length of the side opposite to the third angle. Okay, so this is always true for any triangle, and that's pretty beautiful. The other note here is you can also flip this around. So if this is true, if you invert everything, that's also true. So another alternate version of the law of sines, you could write it like this. This is an alternate version of the law of sines, but we can just use this one. Sometimes this might be advantageous to use. But this is a nice little derivation of the law of sines. So now we can use this to solve non-right triangles. This is a non-right triangle. What I want to do now is discuss with you guys different types of triangles. And let's just do that quickly, and then I'll finish this and go to the next video in which we'll do some example problems. There's a number of different types of triangles, of non-right triangles. We're going to talk about 3 right now. So this is types of triangles. And the 3 types I want to consider are, one type is called an ASA. And what these letters stand for is A stands for angle and S stands for side. So an ASA triangle would look something like this. And it's not so much how the triangle looks as to this really specifies what information you know. So in this triangle, for instance, you would know the angle, side, and angle. Keep in mind there are 6 unknowns of the triangle, 3 sides and 3 angles. You have to know 3 out of the 6 to solve for the rest of the 3. In an angle, side, angle triangle, you know, so these are the things you know. You know one of the angles, you know the side adjacent to the angle, and then you know the angle on the other side of this side. So you know an angle, side, angle. You know these 3 things. And that's one type of triangle. We can use the law of sines to solve this type of triangle. We can use the law of sines. Another type of triangle is an AAS triangle. And this is a triangle where you know an angle, you know another angle, and you know a side. But the key here is the side is not between these 2 angles. So you know an angle, you know an angle, and then you know a side that's adjacent to one of the angles but not the others. This is an AAS triangle. The good news is you can use the law of sines here as well. Beautiful. And then the third type I'm going to talk about, there actually are more than 3 types, but the third type I want to just mention to you guys quickly is this type of triangle. And we're going to call this a side-side angle triangle. In this case, you might know a side, you would know a side, you'd know a side, and you'd know an angle. Notice in these 2, we know 2 angles and 1 side. In this case, we know 2 sides and 1 angle. Okay, this is a triangle that you can use the law of sines. Okay, you can use law of sines. But there's a big caution here. You can actually get an ambiguous case. And I'm not going to talk any more about this right now. On Tuesday's lecture, we'll talk about the ambiguous case of the law of sines. It sounds like a good novel, but it's actually a mathematical principle. The point of this is, these are the three types of triangles that you can use the law of sines to solve. These two, you don't have to worry, you can just go ahead and use the law of sines. This one, you can use the law of sines to solve, but there's a built-in ambiguity that we're going to talk about more. So for now, just kind of forget about this kind. We're going to focus on these two. Okay, that concludes the first part of this video lecture. In the second part, we're going to do some example problems.